Hi everyone, and welcome to part two of Universal Filter. So this is a new way of learning that I came up with after being inspired by reading lots of texts on consciousness, especially that texts like, consciousness is fundamental and the physical world is kind of a manifestation of consciousness. And this is something quite game-changing or quite life-changing for me because all along I've been thinking that, we are just physical beings and the physical world is everything. The brain contains all our learnings. And just a recap of how I got into this. I was attending a neuroscience conference, and in there, Dr. Ho, one of the speakers, talked about near-death experiences, which showed that patients with who are clinically brain dead can still report experiences of themselves outside of their body, which corresponds to real life events. So this led me to think that, perhaps there's something out there. And if let's say we do our learning, we do our memory storage, maybe our thoughts in an alternate plane, and the physical world is just a manifestation of it, then perhaps we can learn more about how, we do this kind of learning and thinking. And hence, this is the universal filter theory. In a nutshell, it's like this. We are capable of tuning in to many different information streams. And all that matters is about how we do the filtering. So for example, if I want to focus more on my sense organs, like my sense of touch, I can pay more attention to it and I get more sensory data from there. Same thing for my vision. You can focus on different objects. Same thing for in perhaps the non-physical realm. If you believe in it, you can use your intent to get information of different kinds of data streams. All right, so the idea of universal filter is about how we can use the idea of being able to filter these information streams for learning, and how do we expand our knowledge such that we can get better and better at filtering different kinds of streams. So um, just a recap on how things are done. First, we have information which exists infinitely. There's so much information out there. Even in the physical world itself, there's so much information and we only capture a tiny bit of it. So how do we capture it? We capture it through our sense organs, our touch, our taste, smell, hearing, sight, and also other senses, sensory motor, or the non-physical senses. Yes, sir, you raise your hand.
Want to clarify what do you mean by infinite dimension for information?
Oh, I just mean that there's infinitely many information out there. Okay, let's take a look at, for example, uh, kind of an object. Okay, for example, take my phone, all right? My phone itself might be one object like this. You might say it's a phone, but if I zoom in, I will see the electrical components. If I zoom in some more, I will see the atoms. If I zoom in some more, maybe the electrons and the quarks. Then after that, you go into the quantum realm, and then, who knows how much layers you can stack inside. That's just the physical world itself. Um, you can see that the amount of information that exists out there is potentially infinite, but the amount of information that comes through to us is limited by how we sense the world. So that's what I mean by infinitely many dimensions.
Okay.
Yeah. Okay. So a lot of our learning stems from us filtering the information from the world and making sense of it because, you can't possibly learn from everything out there, right? Like it's just so messy. So our sense organs are one way of learning. Another way that we can like focus our learning is to use intent. So intent, or in AI terms, we normally call it attention, helps us to get information that we need that are more relevant for what we want right now. So for example, if you are interested to look at some tigers, but you only want to see the tiger on the right, so you can say, I want to look at the tiger on the right. Immediately, your eyes will zoom in to there because you have eye muscles that can go there. You can zoom into the face. You can start to notice more details about the eyes, the nose, and so on of the right tiger only. So we actually are able to sort of guide our senses to sense things that are of relevance to us. Same thing for our sense of touch. Like if you are interested in an object, you will spend more time finding out like what are the properties of it. You can feel it. Okay, you can smell it. You can get more information from it because there's information about all the different objects out there, right? But maybe you're just interested in one thing, maybe the phone. So you spend more time looking at it. Yeah. So attention guides the information stream that we get from our senses. So This intention itself, it can also influence the inputs because we can then change the information that comes to us. Like if I'm interested in the phone, I will spend more time feeling it. I'll spend more time maybe smelling it. I wouldn't say taste it. I mean, like some people might, but yeah. So you might get more information from the object that you're interested in, or from the kind of phenomena you're interested in, just by using intent. And this actually has a feedback loop to guide the information that you gain as well. So actually, this is kind of missing in AI terms. We treat our data information as static. We don't really, do some form of filtering or querying to get the information. That's why RAG systems, the retrieval augmented generation systems, where you first do some form of retrieval of your data by a query and then process those data. I think that kind of system works well in an era where there's lots of information because you can't possibly process everything at one go. Like you might say you have 1 billion token context window, that's still not enough to process all the data in the world. You still need to filter somewhat. And so the cosine similarity using vector embeddings, that's one way of filtering information. Okay, and later we will see there's quite a lot of use for this as well, even in the non-physical realm, how you query your memory, how you query the database and so on, quite related, right? So I would say that we are on the right track for AI. It's just that we need to build the system in a better sense, in a more dynamic sense, rather than just like, hey, this is the first step filter, then move to the next step processing. No, it's not like that. You still have to have the feedback loop across time and so on. So there's quite a lot of insights we can gain here to build directly into AI. All right. So this is the intention part. All clear so far. This is more or less the recap. So I'll just pause here for 1 minute. If there's any questions you want to clarify before I move on to the rest. Okay, sounds good. All right. So what I'm saying is that, right now we have a lot of things that can do like different modalities and so on, like process them separately. But if we do this system right, actually this universal information is the ground truth. And from this universal information, you can get different aspects of your sensory modality from it. And this means that you can model the universal information directly rather than having separate pipelines for each modality. So one way that people are doing it is multimodal LMs, where you can have like audio, vision, audio, image, text, inputs and outputs. So if through multimodal, the tokens itself could be the universal information, because from that token, if you just process it differently, hey, I want this token to be audio, then you get audio stream. I want this token to be image, then you generate an image that represents what that embedding space is. Or from this embedding space, I want to get text, then you do a kind of a next token prediction from that starting context. You can get all this using multimodal LLMs. So I don't think it's that far off. The universal information for like maybe a single entity could in some sense be a multimodal LM. But the universal information for the entire system with all the individuals inside it, that is something a little more tricky, because to do that, you need to have multi-agent systems. Okay, we haven't really got to that stage yet, but once we have multimodal systems, maybe there's a higher level embedding that once you extract from each individual, you extract some data, you can get your own individual embeddings. So that is like what you see over here. You have multi-agent embedding here. The whole system itself has an embedding, and maybe you can query it to get the kind of sense data for each individual. Of course, over here, I don't want to restrict universal information to be just a vector. It could just be a dictionary. Like it could just be like later you see a slide for this also, like individual one, like, and you get the info here. And if we treat the world as a simulation, then it's not too far off to assume that each entity, like in a game engine, could have its own characteristics and could have its own data stream or data storage. And perhaps this data storage is is what we term as memory. Yeah, that we once you access memory, you might be accessing this data storage. So yeah, this is just a new way of viewing things. It's quite radical, I would say. Like neuroscience doesn't really believe that we have a non-physical part of our being, but I now believe that we do. All right. So this is a bit doesn't really correspond with modern science right now, but I think modern science will get there soon. All right. So next, in terms of querying this information stream, I mean, it'll be great if, just from the sense organs and the attention filters is enough to query everything. But in order to do some learning, you need some form of like cause and effects. You need some form of before and after, and you kind of need to have some notion of change. And in this case, the notion of change comes in through time, right? Because if you don't have a before and after state, what exactly are you learning, right? Like information could be just stored as one chunk of stuff, which doesn't really make sense because there's no like, hey, before I learn something is this, after I learn something is that. If there's no state change, I cannot say that we are learning, right? Like how do you define learning if there's no change in knowledge? So I think time is necessary for learning. And so in this case, let's just assume the world is a simulation. I think some people can accept that. In a simulation, you have time and you have the world state. So in every state, okay, every actor will do an action. So like for example, this is the world, right? Let's say this is person one and this person two is a 2D world, all right? And like maybe in time step one, person one moves to the right, and in time step two, person two moves to the left. And so this new state, okay, will be stored here. Okay, so the original state is here. Okay, so this state contains the information of everyone in the world. All right, so where the person is will then be queried by their own individual entity. They can send maybe a query message to the game system. The game system can tell them that, hey, your coordinates X, Y is this now. Yeah, so you could imagine a game world where the characters could continually at every time step query the game engine. Game engine tells them, hey, where you are or what do you see right now. The game engine can feed you that information. And so this combined information is the state. And in the future, you can also get the states of what you will possibly be seeing because you can simulate the outcomes. So if let's say it's a game engine, the game engine simulates the outcomes. It's like, chess. You can simulate the future outcomes if you already have the physical space-time rule set. You can simulate the world, get the future outcomes, and the future outcomes are not just one outcome because if let's say we assume free will exists, then each individual has the choice to choose their own actions. The future would be a fuzzy future because it will be like a mesh of different probabilities of potential outcomes. And like only one outcome will be realized. And it's basically the outcome that will follow after each individual chooses their actions. So over here, this is something to note is that if we want to query stuff in the future, it will never be certain. All right. It's hard to be certain for anything in the real world because there's just so many actors in the world. Like maybe you can be certain if it's a very constrained world like chess. All right, you already narrow down the rule set into even more narrow than the space-time rule set because you take away everything that is non-deterministic. Then you can have 100% certainty. But if not, what you predict the future would be a fuzzy future. This applies for self-driving cars as well. So you have a car over here. Okay, my car is not very well drawn, but if you have a car over here and you want to know like, hey, what's in front of you? All right, there will be another car over here, or maybe there's another car over here. This car could potentially speed up and cause a potential collision. This car could speed up also. So you need to kind of continually assess based on the previous trends, maybe the nature of the driver. You kind of predict where their car would be. And this is not certain at all. Okay, you can never be certain about this outcome because there are factors that lie beyond your control. There are external factors that lie beyond your control. And you can view this as a black box. Even for the game engine's perspective, it is a black box for the game engine as well, because if we assume that free will exists, you cannot control the actions of your individuals. And you also cannot really predict what they will do because if you can predict everything, then there's no free will for the agent, right? Like so assuming like you offload your tasks to multiple LLM agents, okay, you cannot tell for sure what the LM agents will return back to you, right? So the outcome of your agentic system might be fuzzy because you don't know whether it succeeds or not. So this is the future outcome. So the future outcome is not just one vector. Over here is just for simplicity. It could be multiple vectors here. Each one of them has a certain probability of occurring. Like maybe this is 40% and this one is 60%, like depending on what is most likely the action to be output by each individual, you can have different game states. All right, so this is slightly confusing, but this makes sense because in the world, nothing is certain. All right, so this idea of having multiple future outcomes makes sense. And what you can do if you want to get this data stream, right? So this is a little controversial here, but you are actually, some people believe in this thing called the Akashic Records, where every individual here, the actions are stored in some cosmic database, and then you can query the past, the present, and the future. In fact, the past, you can also query like what are the different kinds of pasts that exist. Like if one action is done instead of another, what would happen in the past? You can query that as well because the system stores the future outcomes, and in the past, there's also different outcomes that could happen, but there's only one realized past, like one state that actually happened. So yeah, people can actually query the databases to find out what happened at what time with what person, what the person is feeling, where that person is. So these are all possible with the right intents. Zhe yes, you asked a question.
When you talk about querying the alternative paths, are you talking about something akin to counterfactual reasoning?
Something like that. So you can say if person A did action A instead of action B, what would have happened?
Okay, another thing is this, what you call it, Akasha database?
Yeah, people call it Akashic Records or like database of or
Is it kind of like a hypothetical construct?
people have queried it before, like psychics have queried it. Not everyone
Oh,
knows how
okay.
to do it, but
Okay.
I myself haven't done it, but there's quite a
Because
lot of
because from the
anecdotes of it.
counterfactual reasoning framework, it's most of the case it's impossible to construct a genuine counterfactual case simply because that path simply does not exist. So you can try your best to create something as similar to the counterfactual scenario, but it's never genuinely realizable. So that's why I was wondering what are you talking about?
Correct. So actually, even in the past probable states, they are also not 100% guaranteed that they will happen. I mean, they didn't happen, of course, but it's also not 100% certain that that would be the case if this person did the action because you still have to account for the rest of the world, right? The rest of the world
Okay.
might change their actions based on this person's change actions, but you can only do your best possible prediction of like if everyone does their most probable action, what is the outcome?
So
So
is that a probabilistic framework as well?
that would okay, let me just draw the timeline for you, all right? So let's say this is the past, right? So the past, the present, and so on. So you have different kinds of, and the future would be like maybe different strands out there. In the past itself, you could also have different branches that could possibly happen but didn't happen. So essentially, you are querying one of these branches that didn't make it to the final timeline. Like you're querying one of these nodes.
So can I think of this as a Markov chain where you can there's certain transition probability from one node to another node, something like that?
Yeah, the whole thing is a Markov chain. It's just that not every single node is the actual like path of the world. Like for example, the state of our history is here. There's many unexplored states that didn't actually happen because we didn't choose that path.
Yeah, sure. I mean, that's just condition on the actual realized path. So,
Correct. So if you think of it like a tree search, we are searching a tree of possibilities, but the past few transitions are fixed already. We condition on this as our history,
okay.
and then the future is all here.
Yeah, okay, Ken. I'm just trying to link to what I know. Yeah,
Does it correspond to what you know?
I mean, yeah, I think I can understand from the framework I already know to understand what you're talking about. Okay.
Yeah.
So I'm trying to understand this part of the framework, the time step. Um, is the other branches are what is the difference? in this framework between querying the other branches and simulating the other branches. Do you like understand what I'm trying to figure out? Because like I'm trying to
Okay.
understand what the difference is between like this Akashic record, this kind of like you're querying a database of all possible timelines, all possible previous time steps, and then just simulating that time step in a kind of tree search or a kind of expanding graph. I'm just trying to understand what the difference is in this framework.
Okay, so actually there's no difference. Querying and simulating is no difference because when you query a future state with a certain kind of intent, which is like I want a future state of this person doing this action, or like I want a future state where I want to see what's happening in 2050 in this location. You know, when you do some form of query like this, essentially what the game engine will need to do is to simulate all the future outcomes based on the highest probability until that point. So the simulation is done prior to querying. In fact, actually, the simulation is already done. Like you must assume that this computer that can simulate the reality that we are in right now is much, much more powerful than any computer present right now. It's able to compute the from start of the universe to the end. It's able to compute the whole thing like in less than the time that takes to the time takes that move the reality right now. So like for example, if one tick of the game mode right now is like 1 millisecond, then you must assume that it's able to compute this whole thing even before that 1 millisecond. So everything has been pre-computed. You're just querying whatever that you need to and getting the information back. That's one interpretation. The second interpretation is when you query, the computation is done after you query it, and you get it almost instantaneously because the compute is so powerful, it's able to compute the future like just like that. Like I mean, I believe in it because quantum computing can actually speed up processing quite a lot. And if there's some computer that can simulate our reality right now, it definitely must be much better than the best quantum computers that we can build. Yeah, all right, Derek.
Okay. Yeah, okay, I think I get it. So the nuance is the difference between internal simulating slash querying and external simulating slash querying. So basically, this framework is basically saying that you can kind of offload the computation almost by interfacing with the external Akashic Records database, what have you, offload some of that computation and just do a query slash simulation kind of interfacing with that external model. Am I kind of getting it or am I off?
Mm, sorry, can you repeat that again on the querying part?
So I'm just trying to understand the nuance of this framework and the interpretation. So you have a nuance between an internal simulation, like simulate within your internal world model, and simulating past possible time steps, future possible time steps that aren't of the current are within the current line or branch. And then your framework integrating this more external database, right? Or no, I don't think it's related to universal information. I think it's separate. Kind of this external database that you can query for all possible timelines or previous time steps, etc. So I'm just trying to understand: is there a computational offloading, or is there no nuance there, no difference? Like all the computation stays the same, regardless of if you're doing an external interfacing or an internal simulation. If that makes sense, I'm just trying to understand what this part is trying to like state or like accomplish.
Mm, I mean, in some sense, external or internal doesn't really matter. What matters is once you query, you can get the information. So it might be internal to our reality. Actually, it should be external because our reality moves at a much slower timestamp than what this computation can do. So it is likely external. It has to be external. I mean, if not, how can you compute the future with just one time take of this world, right? I mean, one time take you can only compute one step. This querying can go multiple steps in the future, so it has to be external. Yeah.
Gotcha. So if we're interpreting the framework from that aspect, how exactly is the framework taking advantage of that? I guess that's my point. How are we taking advantage of that interpretation if that is the true nature of it.
Okay, so this is a little controversial here, but this is the view that I have after reading lots of text. What we view as intuition, all right, like suddenly you get an urge to do some action, might be someone like guiding you to go to a possible future branch of yours that is more likely to improve you, and that intuition can filter back down to the you right now so that you can do better actions. Like that is a little controversial here, but some sense of or what we should do in the future is able to trickle down right now into the present, even without your conscious like intent. Like there's some notion of that is intuition. And the other thing that people can do is that if they master how to query it, you can query it yourself, of course, but most people cannot. Like most people don't hone that skill. So this is I think there's some aspect of this knowing the future and guiding your present self that is present in each and every one of us, because there's always some intuition that tells you, hey, this is good, this is not that great for you, like some vibe that you feel, and that vibe might actually come from this future computation and then tells you something that you should know right now. So I wouldn't say that we cannot know this database. It's just that we don't see it as a database. We just think of it as intuition. And science has explained intuition as you have your past memories, you see your stimuli, and then you, based on your memory, and then you try to, infer what's good for you subconsciously or unconsciously, and that springs up to your consciousness as intuition. And I mean, that's one way of viewing it. But another way is that, we might already know what branch of future we might be, and that springs back to you as intuition as well. So there's no right or wrong for this because I can't prove it. But I would say that it makes a lot of sense if we are able to get some information of the future and trickle back down to right now, so that you are able to choose more promising branches for yourself. Yeah, so at least that's what I believe in. So a lot of times people, try to simulate, like maybe for example self-driving cars with purely physical senses. Like for example, you use LiDAR, use vision. What if humans possess a kind of sense that exceeds the physical world? Like for example, we could sort of sense whether or not there's a car coming. Like it's just this feeling that we have, like, hey, there's this spot here that I didn't check. Like is it it, is there something that like there are some telltale signs that maybe you don't even realize, but it's just there in your cognitive processing that prevents collision. So so to me, I think one of the reasons why we haven't really been able to do autonomous stuff right now is because we don't really have a way to model in this intuitive sense to prevent collisions and so on. Sure, we can do it in one way. We can do it in a very constrained environment. Let's say you have self-driving cars and you constrain all the roads to move on tracks or something like that. They have no people crossing. You remove all the extra factors. Yes, then autonomous systems I think will work. But if you want autonomous systems in the true free world, like the human world right now, this reality, I do think you kind of still need to model some form of future prediction back into the present timestamp in order to better guide actions. This in AI sense has been referred to as tree search, like Monte Carlo tree search, or like some form of simulating the future and using the outcomes to inform the present state. Like that's what they do in tree search. AlphaGo, AlphaZero, Deep Blue's algorithm, which is the minimax algorithm, alpha beta pruning, all this all have some notion of knowing the future and trickle it back down to the present to guide actions better. So I think that's sort of what uh, we are kind of missing right now in the AI space. We can do tree search, of course, but the tree search we do is very, how would I say, very constrained. Because we cannot simulate tree search for all entities, you see, that's too much compute right now. But the moment we can, and we can model this future branch and trickle back down here, I think we would have solved quite a lot of AI problems. Yeah, that's my opinion. Okay. Yeah, I've talked quite a lot. I hope it's still understandable. Yeah.
It is. I have a better understanding. I kind of get where this framework's trying to come from. So it's the idea that with machines, they waste a lot of compute trying to come up with an absolute guaranteed answer almost. And kind of like what this framework is arguing is basically saying, hey, maybe we don't do all of this at every time step and try to, control everything. Maybe we just spread it out and we use a more general kind of pattern recognition or more general higher level sense that's more about vibes and more about like higher level pattern recognition than trying to like I guess kind of like punch in as much compute as possible to get an absolute guarantee, which is not possible just because of the amount of variables you're dealing with. So the way mammalians and humans have learned how to navigate our world and learn the rule sets of the world is kind of like more general conditioning, a more general kind of feeling things out, a more kind of like a vibe sense almost that we have. And that's like I think that's what you're trying to kind of like show in this framework, kind of like with the possible time steps, future and past, and the other kinds of intuitions that we're able to access, whether or not we're interfacing with this Akashic records. It's kind of like that. It's basically kind of like our way of just kind of like interfacing with the records and kind of like feeling ourselves out, feeling out our future potential states, as opposed to spending too much time trying to take every variable into account, if that makes sense.
Yeah, definitely. I think there's no way for us to process all the information that happens in the world. So definitely some form of heuristic is useful. I mean, that heuristic could be encoded as a byte. So like for self-driving cars, maybe this heuristic could be, could there possibly be anyone out there that can spring out from that section? Like, so for example, when you drive, you see an occluded wall, maybe you slow down a bit, make sure that you see something there. Yeah, I think it's all possible to program all this in. So I wouldn't say self-driving cars would not happen. I'm using self-driving cars here because I think it's quite close to human navigation. And once we can crack that, we can crack a lot of other things. So there's some things that could be explored as heuristics, but the human mind is much more than just heuristics for the road. But of course, if we just want to do self-driving cars, we can distill such heuristics down, put them in the car. So we just don't rely on, just the sensors to tell you what to do. We also have certain kind of like vibe or like what people like to call heuristics to, to make sure that we check certain corners that usually might have something coming out. Yeah, so this I don't think the AI system will just learn this just from visual observations alone. Like there's another sense that is needed to be encoded in. Yeah. Okay, so yes, you raise your hand.
I would like to point out two things. First, from legal perspective or legal implication, um, I feel it is very hard to justify incorporate things like heuristic, very heuristic based or even like vibe based um, logic as part of decision making uh, in your system, especially in the real world, like high stake use case such as self-driving. Like, how are you going to justify the decision made in some very critical situation just based on so-called vibe? I feel it's gonna be very hard to justify that. That's my first point. Second point, I have a kind of rather different understanding of the vibe here. So when you said okay, let me ask a question first. So do you think the vibe checking route costs more or less computation compared to currently how we do like very rigorous or logic based or just processing the signals, and which route you think costs more compute?
I mean, a vibe is actually a compute as well. Yeah, computing
Yes,
the future branch and distilling some knowledge
yes. So
in the
which
future.
one do you think is more computational intensive?
What's the alternative?
How it is done now at the moment?
which is no vibes, just using the process itself,
Which one
right?
you think is more computational intensive?
Right now, I don't think we can do the vibes thing quite well because we don't have like the future simulations feedbacking right now into the present state. Maybe you can definitely it is computationally intensive because Monte Carlo tree search, you can't even search beyond a certain depth because like it just takes compute and takes time. But in the future, once we have better computing systems, we will be able to compute much more deeper and much more wider and can, like potentially simulate the future much more than right now. And that's going to change a lot of our AI systems because it will get smarter. You will not do certain branches that are not good because you can already see in the future that it's not very good. Like so the vibe thing can come just from simulating the future. It is computational intensive. It is. I'm not gonna lie about this. It's not easy to simulate the future.
But okay, let me share my understanding. So I feel like this vibe thing can again link back to system one versus system two thinking or learning. So the reason that I think for human at least we don't feel when we talk about vibes or when talk about gut feelings, right? It doesn't appear to us it costs us more energy to
No,
think
it
compared
doesn't.
to
Yeah,
compared to
because
explicitly doing the computation, right? So my theory is it is because vibe emerges from um when you already done the system two thinking. So it's already you already formed the circuitry in your brain, like or the experiences you accumulated in your brain. Then this you do not need to learn new things. It's like a very fast feedback from your existing experience. That's why it doesn't feel as computationally intensive compared to when you first want to learn the things. Okay, so it is pretty I think it's pretty evident because you wouldn't have so-called vibe if you don't have enough experience. That do you agree?
yeah, so that's
Yeah.
one kind of intuition. That's intuition from your past. So
Yeah.
yes, you can have that intuition as well. From experience, you can
No,
get.
no, even for predicting the current future, you can still base that can still be based off of your past experience. But in fact, at the moment, you are trying to predict the future.
Definitely. So
Right.
that's one form of vibes in some sense because you have past memory. You can use that to guide your actions, and that is very in line with the materialistic view of how we think. Like we use our experiences that shape our actions in the future. I believe in that.
And
So,
another thing is,
yep.
I feel it is actually when doing the vibe checking or the gut feeling thing, you are actually implicitly modeling some variables as latent variable. Like you are not maybe not consciously aware of, but you are just in maybe you are subconsciously modeling it as a latent variable. Uh,
Mm,
yeah.
yeah, definitely. You have to make some abstractions here to use your past knowledge to guide.
But the reason you can do it without explicitly modeling is because you have enough experiences to, just very fast based off some cases you already encountered in the past. So you
Mm.
can do it in that sense you already pre-built the model or the framework. So
Okay.
it's
But this explains only certain parts of our actions. Sometimes you always like, for example, take path A, but someday you might say, hey, I think path B might be good today. Like suddenly out of norm, you break your habit just to do something, and then maybe you meet someone there. Like some cases like this are hard to explain with past experiences because in by past experience you wouldn't break your habit.
right. Okay. But then this again link back to my first point. You can't can you how do you justify to incorporate such esoteric factors in your system then in such a critical use case? It's hard to justify, right? It's not
You can
reliable.
justify because you don't have to say it's a vibe. You can say it's a man-made heuristic that looks into future simulations to get some form of like value or guidance to the current system. So
But you don't even know where it comes from because you
it
saw
can
it's just
be,
kind of something almost like a premonition. You don't
yes,
even have
yes,
any reasoning to support
you
it.
have reasoning. Because if you are modeling it for a constrained system like self-driving cars, your reasoning can be, hey, I need to check the corners to make sure that there's no pedestrian coming up from it. Yeah, that occurs naturally in humans as a vibe. But for systems, you can be explicit and model that in.
But that I think that can be explained by past experience, right? Because
Yes, that's true. So you're okay, I get what you mean. There are things that are beyond past experience that cannot be modeled by just a process. It has external factors involved.
yeah, I think the dilemma is here. If it is not based on past experience, it's hard to justify. That's the dilemma here.
Yeah, I'm still thinking about this. Like, I think you made a great point here. Maybe just using the heuristics alone may not be enough to account for how humans might actually be processing the world. Like there might be more at play. But for AI systems, I think you have to have some limit. I mean, like there's is how do you model vibes from I think the best is like doing some simulation and distilling knowledge back. Yeah, that's the best that you can do. And that's purely explainable. People can buy it. You can just treat it as predicting the future and using those predictions to guide current actions. I think that's perfectly acceptable in AI terms.
Yeah, I think if you put it that way, it sounds much more rigorous and easier to be accepted.
Yeah, actually all this can be framed in conventional AI terms. I'm just telling you about all the non-physical parts because like I'm trying to link this to our reality. And from this you can build AI systems. Because my belief is that okay, this is a bit controversial. My belief is deep down we are all like entities in the computer system. It's just the computer is not the computer here. It's a cosmic computer.
But I guess the point, the like the consequence of that is you are trying to have a framework that's in which your so-called vibes or the premonition is explainable, right? Otherwise, what's the point of the simulation?
You can explain if you dig deep enough. But the thing is about this vibes is that it's not an information download, you see. It's just to tell you that, hey, shouldn't do this. But you may not know, or most of the time you won't know why you shouldn't do it. It's just a feel. And
And how does the simulation hypothesis explain now with this framework? How do you explain now why sometimes you want to follow your vibe?
it can be explained as a information processing kind of limitation. Perhaps an individual cannot download a stream of experiences as well as the computer can compute. So the computer can only put in certain information that is understandable to you.
Okay,
Like,
I think we can discuss more offline.
yeah. I think there's various ways to model this. But after discussing with you all, I do feel that this kind of like querying the future thing or even querying the past. So querying the past can be viewed more as using experience to guide actions. Querying the future could be simulating the future to guide experience. So I think both are already done in AI systems right now. So there's nothing controversial about this. So
Mm.
that's great. That's great. So in some sense, we are actually modeling some form of Akashic records already in our AI systems. It's just that our scale is not there yet. We just need to model more.
But I think there's a subtle difference between modeling a future by simulating it versus just based purely on some kind of uh like cryptic vibe where you can't even explain where it comes from. Because you're
Yeah,
not
yeah, no, it just goes back to my argument, the whole internal external thing. So are we doing this internally or are we doing this externally and interfacing with an external knowledge base? It's I don't know. It might be a catch 22. It might not be super important right now. We might just need to focus on the principles of what we're accomplishing and then just worry about the marketing later. I'll put it like that.
Mm, I think the database has to be external because it contains everyone's experience. I didn't mention this earlier, but this database contains not just your experience, it contains anyone's experience, and you can query how anyone is feeling at any moment in time, where they are, what they did. In fact,
I mean, almost like hive mind kind of thing.
right. In fact, this is a little controversial again, but psychics have helped police track down criminals by querying this database to find out where they are right now. So it is possible to to query other people's actions as well. So this is more than yourself. This applies to other people as well. But I think if you don't query it, what trickles down to you is mainly for yourself. It's not for other people. Yeah. So there's something external at play here. I don't understand the full dynamics of it. But definitely if you are someone that believes in intuition a lot, you can't really explain this intuition with just past experience. Like, because sometimes your intuition tells you to do something totally different that you have never considered before. You can't really use your past memory and experience to explain this. But if you use a simulation hypothesis, you model multiple futures and trickle back information back to your current self, it makes sense. It's just that the compute is not done in your head. The compute is done elsewhere.
Yeah. So it's almost like there's something in this simulate the type 2 to type 3 to future probabilities. There's almost like there's something, some general algorithm, some general heuristic that we just haven't tapped into that's going from present to future for simulation that's allowing almost allowing us to kind of like get these probabilities and these foresights that we wouldn't be able to get normally with like say like just previous, like we can use the previous querying and the previous memories as a conditioning for our future simulation to reduce compute. That's fine. But there's something else in that simulation, some algorithm, some heuristic, whatever, some generalization algorithm that allows us to have this intuition, like, and have true intuition, not just like programmed heuristics, almost a true general intuition. There's like almost something in there that allows our future simulated probabilities to like have a, what do you describe it, like have a deeper layer than just pure simulation, if that makes sense. Like there's something in there.
Yes. So it's not just modeling your future with other people.
Right.
There's also some factor involved that tries to guide you to certain actions that might not be beneficial for you actually. It might also be because you are needed for someone else's growth. So it is, I mean, this a little bit going to the like religious realm here. Like there's a lot of like actions that are like what you might say as coincidence, but it could already be like mapped out in a grand scheme of things so that like certain people can grow. I mean, like maybe one instance would be like if we talk about the Bible, like Jesus, he actually had quite a lot of help from people that like he didn't know, but they just happened to be there at the right place and right time. And I mean, not just Jesus, like even you look at your own life, like certain things can happen that, you may not expect it to happen, and that led you to a different kind of outcome. Like so this is something that um I mean a lot of people can attribute it to, hey, past experience, opportunity, but it might just be that, there's certain guiding forces externally that tries to guide you to the right path. So I don't want to delve too much into this because it's moving further and further from AI and more into spirituality, consciousness. But um, there might be something at play out there that is external to the self, and I agree with that. Yeah. So yeah, Karen, you asked a question. Can we use the counterfactual past and future to modify the real future, or like modify the real future's probabilities? Mm, you don't need to use the counterfactual past to modify the real future actually. Like you can just modify your own actions and you can change the future already. So basically just by doing a different action, you change the future outcome because you are part of the future, right? And of course there are other ways to modify the probabilities as well. Um, like some psychics have also said that, if you put enough intent into a certain future, um, you might be able to influence reality to go to that way as well. Like not just your physical actions, but your thoughts can actually influence reality. So that a little hard to prove, but I do believe that every single one of us can modify the future because we are part of the future, be it both physically or as consciousness. Yeah. So okay.
Sorry, John. I have a question. Uh,
Yes.
yeah, I was just wondering, like, is there some sort of deductive reasoning that the AI models have, like generating counterfactuals and um, if this were true, what would happen, and modifying the predictions based on that. So, do we have anything like that in the AI models? Because I don't see here
You mean
there
for
yet.
factual pass, is it, in AI models? To model
Yeah, deductive
factual pass.
reasoning or reasoning through counterfactuals. So they can predict a certain event, and if this were to happen, some other event would happen, and based on that guess, modify the probabilities. But this is like how Sherlock Holmes tries to, uh, deduce things. So he's also looking for clues, but he's also uh, imagining things. If these were true, something else would happen, and based on that, eliminate other possibilities.
Okay, so it's not really modifying the real future, but you are trying to use whatever knowledge you think the past has to see whether it fits with the current timeline. So like if person A did this, does it work? Does it still match with what I observe? Or it doesn't, then it's out. Then it's probably not. Then person B did this, does it match with the current timeline? Yes. Then yes, this is a potential hypothesis. Is that what you mean?
Yeah, like if you can use this for inferencing what is really happening, or what can really happen. It's more for deductive purposes, like to when there's not enough information and we are trying to create these scenarios and to make use these counterfactuals to get to the real truth, like what really happened or what is really happening.
Hmm. Yeah, I think you can use this to do logical reasoning. You don't have to modify any future to do logical reasoning. It could just be logical inference on evidence that you have seen, and try to use that to, see whether it makes sense with what you have seen so far. Like whatever you have observed, you you look at the observation and try to match with potential logical deductions you have, and then you can eliminate those that don't match. So there's nothing to do here with predicting the future. It's just observing what you have seen and making sense of it. Yeah, so I don't think you need to use anything to modify the future for that, if you get what I mean. Like it's more of inference with,
Yeah. Okay.
yeah. Okay, so that doesn't really contradict with any of this theory here. So this theory in AI sense, very simple. So I think if you take away all the psychic elements of it, which I'm not too familiar with, by the way, I'm not a psychic myself, so I cannot say like, hey, what can you see, what can you not see? It's mainly from videos that I've watched, mainly about Tom Campbell and like how intuition works and so on, that I got some nuances of how this might have worked, if you believe in it, of course, because not everyone has access to this. Uh, but he says that everyone can train to get it, but not the fact is we don't consciously do this all the time. So this could be memory, and this one could be like some form of intuition about the future. So yeah, I mean you don't consciously do this, but it could be information fed into you by the system, even though you don't think about it. Yeah. So you could just suddenly get this rare insight and so on that suddenly just comes to you, like, and that might be a result of experience and so on, but there's no doubt that this might be a life-changing thing, that you know if you use normal AI ways to model this just from past experience and memory, you're only seeing half the picture. Like I think this is the current half that we are seeing right now. AI agents with memory. Like over here, this is the potential future for AI systems, where you actually can do some form of modeling the future and get some insights, actionable insights for the present. So I think this is something that some people have tried to do. Like for example, AI researcher like Sakana AI, they try to model like potential topics and then see whether is it viable to explore them. So perhaps then they can get some intuition. Maybe after you do the paper for that topic, you might like, actually this is not a very useful paper. Maybe I'll do something else. So something like this. Once we can do some modeling for the future, and this means that we need to be able to model a simulation. Okay, either you can model the simulation, like for example world models, or you are given the simulator. And I think more likely what will happen is we need to be given the simulator. Okay, because like you can model the simulation, but this model is at best an approximation of what's going on. Like I think this is very hard to learn on your own. But if you are given the simulator to play around with, then it makes more sense because from that limited experience that you have, that limited world experience, you already know what's going to happen. So case in point is like this. The question is physics learned or given to human? Do we know physics intuitively or do we learn it from observations? Oh, this break drops down or this objects get occluded and so on. So this question that has no answer. But I do think that because we are able to, get some intuition about the future once in a while, maybe we don't come with a blank slate. Maybe the brain itself already has some form of physics model in the 3D space-time. Like there might be ways to perceive objects in 3D that already sort of inbuilt in the structure. Yeah. So this might mean that you don't really need to do your own world model, you see. Like maybe you already have the world model and you can play with it. So this is a huge topic actually in AI. Like how much can we model in the world? Like how much can we learn from experience to do your world model? A huge topic on this, on world models. And I think just by a limited experience of an individual, like one person, it is very hard to model the world. It's really, really hard. You need a lot of experience. You need a lot of data. You just take a look at people trying to model the world using maybe language models, like large language models. Like you can't just feed in like one person's data and and hopefully use that to model the world. Very difficult. You need a lot of data from different people. So I don't know. This is an open question. I don't have the answer to this. But I would say that in order to do the simulation better, it's best that we already have a ready-made simulator that we can just use. So this means that if you use the ready-made simulator to model the future like this, if the game world changes in terms of physics and so on, your model will all be wrong, like because your simulator doesn't change. But if let's say the game world changes and you're given the new simulator, then yeah, you can use that to model the future. So I don't have an answer for this, but I think in order for AI systems to work better, I think I prefer the simulator being given than modeled by a person's experience because it is very, very difficult to model your simulator just by one person's experience. Okay, let me give you an example. Assuming you have a simulator where you are trying to model like maybe a person that can transit from point 1 to point 2 and so on. So like this is a maze, right? Maze can go up, down, left, right, up, down, left, right, like so if just by doing this alone, yes, you can take the actions and then your cells, and then you can see like after a while you learn enough experience, you can sort of model the whole world with just this 4 actions. I've done this before, like learning fast and slow. You can use the previous state, the action, and the next state to kind of model your basically given your system, which takes in the system and the action. Oh, sorry, takes in the state and the action. You can use some form of neural network to get you your next state. Then you can also do this with large language models. You can feed in a stream of experiences and ask them to predict the next state. It works quite well because next token predictors kind of learn the patterns, right, of the transition probabilities and so on. So this is all well and good, if your action space is just like 4, 10, but once you get to the real world, our action space can be huge. It can be like uncountable. So if you were to like learn the simulator from our own from scratch, I don't think a lifetime is enough to learn it. Yeah. This is just my view. Yeah. So I do think that some form of a simulator is given to us. Like if not given to us, is present in the way we query and get information from the past or the future. and that informs us what to do. So this is a bit controversial, but I do think that we kind of have some form of like intuition about what can work, what cannot work. Like we don't try out every single possibility. Yeah. So any views on this? Do you think that we learn our own internal world model, or we already have a model of the world? What do you think?
I mean, there's clear evidence for both, right? Like from human body structure, it is very clear that there's already built-in inductive bias in our genetics that makes us compatible with learning in this 3D world. So there's a very clear evidence for the case one, but for case two, like we also, I think we get intuition from experiences. So we also learn through experiences. So I think there's clear evidences for both cases.
Definitely. I think world models about like how people, like theory of mind, right? How people behave and so on, that can be learned from experience.
I don't know. Okay. The specific example I have in mind is, for example, in like basic physical law, inertia, gravity, things like that. So I believe even if you don't have a built-in pre-existing inductive bias, you still can build your intuition through learning after you are born. Like I can totally imagine a world where gravity works in the opposite way. Like instead of attraction is repulsion. But if you are born in such a world, then you will find it very intuitive. Like things don't attract each other, but they repel each other. It's a matter of experiences. Yeah.
So you are saying that once you have some initial biases, you can learn the rest of the world yourself.
No, I'm saying intuition is largely built on experiences. But I do but I mean I do agree that certain things you cannot learn if your physical inductive bias is not built correctly. For example, even though we see actually, we see 2D images through our eyes, right? But because we have two eyes, even though we see 2D, but our brain can post-process the information to give us a 3D like simulated 3D immersion experience. So that's the evidence for pre-existing inductive bias in our genetics, right?
Yes.
But the experience. So given that it is possible to learn certain things, then I'm arguing that actually you just need enough experience to build the intuition. No matter how weird you think certain things are, but if you are born in that kind of environment, you wouldn't find it weird. Yeah.
Yeah, so that's what we were talking about, right? I think intuition, you can view it from the past, but you can also view it from the future. And I think the future one is not by experience. Yeah. So I mean, I think in terms of let's talk about AI systems in general. I do think inductive bias is important, and I also think that a simulator is important because the more I think about it, the harder it is to model a simulator from scratch. So what would likely be the case is that your simulator is trained from a lot of experiences, maybe if you don't have access to the ground truth. Or you could just build a simulator that is so detailed, it matches what we observe. So in some sense, the simulator in our physical world could be like game engines that model the physical world. And there are some games, like for example, Gran Turismo, that model the world out there for racing cars quite well. That is used to train competitive races. Okay, I don't know whether it's used to train competitive races or people try to mimic competitive races for it, but it is very likely that we'll reach a stage where our like virtual reality gets so close to the real world that you can't tell the difference. Then you have a model of the world. And with that model of the world, you don't need to rely on experiences to learn the transition probabilities and so on. When certain actions are done, like you move a brake with one, like with a force, in a certain direction, you already know the end outcome. So when this is done, you can do this simulation modeling and get insights from it very accurately. Okay, because what's worse, in my opinion, is that we get a wrong simulator of the world and we use wrong insights to guide our actions. That's worse to me than having no intuition at all, because guiding you to do the wrong actions, especially if this intuition happens all the time, will lead you to exploring wrong search spaces. So this is my gripe with so AlphaZero, right? I've done some research on it. Like if your value and policy networks are not tuned properly, it will do the guidance to the wrong state spaces. And I've tried it. Like if I train it to the wrong like end outcome, and I just change the game state a bit, make the break move. You can check out my paper. It's called Break Tic Tac Toe. It's on archive. So if you change the break to another position, AlphaZero takes quite a while to adapt. Yeah, in fact, it might not even adapt at all because what will happen is that your policy and value networks are all tuned towards a certain exploration. Let me draw the graph for you. So let's say your policy and value networks. This is your tree. Let's say your policy and value networks only search this branch, but actually the optimal branch lies here. Essentially, you have to unlearn this part here, which takes very long. And what will happen is that you will keep making wrong and more wrong moves, and your experience that you get from wrong intuitions, will shape the world model wrongly even more, because like you explore even more at this site, and what will happen is that you only get experiences from like the wrong branch. You never explore the right branch. So what you will get is maybe this branch is like very, very bad. But the problem is with credit assignment, you never know where's the wrong action. So you might just blame it on like or you might attribute it to one of the nodes at the bottom here. And then you might explore another node here. And since there's like potentially, okay, I wouldn't say infinite for Go, but for real world, there's potentially infinite actions that you can get at every node. You might end up getting stuck at the wrong branch forever. And that is something that I would try to avoid. So to me, having a good simulator is very important. You can say you learn from experience with the world model, but except for easy cases like this, up, down, left, right, I honestly doubt that one single person's experience is enough to learn, especially if the state space for action space is unbounded. I don't think we can model the simulator just from actions alone. We kind of need to be given the simulator. So that's my opinion right now.
Can I chime in here?
Yeah, go ahead. Yeah.
So I think the example you give is a very good example of why, despite we have many very clever tricks, many clever methods, we still need better and more raw computational power. Because you see, none of the method works back in a few decades ago, right? And it's only with the abundance of data as well as exponentially more powerful computer or hardware, we are able to achieve what we achieve today. People always argue, okay, human, we use energy very, very efficiently to do reasoning, to intelligence. But I just give you like very simple example, playing chess or Go. The average human who just learned the rules, who just is the beginner level, they can barely like think ahead of like 2-3 moves, right? At least that's my own experiences. I think most of the people who are not prodigy or not talented in this, that's the case. So isn't that like a case or evidence of, okay, maybe we use energy efficiently to some extent, but you see, in order for this kind of thing to work, you still need many years of experiences, so that you do not, every time when you have the experiences, you use the fast thinking, you don't use the slower thinking that use more energy. But in any case, cumulatively, you still use a lot of energy. And for AI system, we have so many good tricks, but it only works if our raw computation reach a certain threshold. So it's like a combination of both clever methods, algorithms, and raw computational power. It's like the beta lesson all over again. Yeah.
Yeah, so definitely the compute is important, and I also think you agree the world model is important. So previously, I always had this thinking that you don't need to model the world so much. You use memory to model the world. I think that may not be sufficient. So with this new insight that I have, like we likely, I mean, maybe using memory will work most of the time. I mean, this is our default state that we use memory to guide us. But occasionally, when we are in the wrong track, there needs to be some intervention that tells you, hey, you should do this. Yeah, so I call that intuition. So like that is something that helps to steer you back on track, especially if you go wrongly based on your experiences, so they can get better experiences. And yeah, I think that is, so this is to me, this is the curse of memory. Like too much memory might lead you to not explore anymore. Because like you always think that, hey, this is good. That's why you get to a habit of like going to path A all the time. And then it's like path A is great. Why should I explore path B, right? Like, so some way or another, like we are born to do some explore and exploit. So sometimes you will explore some other state, like maybe one day you would try to think of path B to explore, but most of the time you won't. Okay, because like exploiting is quite comfortable. Like if you are comfortable with a certain route, why will you take a new route, right? So that is something that you can solve if there are two ways to solve it. One is someone gives you new experiences, like your friend drags you to somewhere else, or you just have like I don't know, some like a memory wipe. So the memory wipe in the consciousness terms might be starting a new lifetime with no memory at all of your previous lives. Yeah, so that might be one way to get you to experience something different. Um, in like if you talk about physical systems, this memory wipe might be you just forget your memories over time, and then you might try something else. But I think that memory wipe is not very useful because not saying you're useful, but it's not that life changing because generally the traumas that you experience through life, you keep them through life. Like if you fear something, your fear doesn't exactly diminish over time, you still fear them. Yeah, so there are ways to cause people to explore more, and I think more effectively is this one. In one lifetime is this one. Like there needs to be some, like either your friend or like your inner guidance telling you to do something else. That might be a way to get you to explore something, and change your course of action. Yeah, because if we just rely on memory alone, you might just do the same thing again and again. And this is a problem with AI agents, by the way. This is the problem with AI agents and memory. Because if your memory gets accumulated and memory is wrong, it's very hard to change it. Yeah, because your memory will guide you for your actions. And your actions, if they are wrong, you keep doing the wrong actions. And then maybe there's so many actions down there, you might attribute the cause to a action that is below the chain, and you will never change your top action. Like for example, if you do Google web search, you might search many things down the chain, and you might say that, hey, it's maybe my query at the last step that's wrong, and I'll change it. But in order to know that, oh, it's my first query that's wrong, it's very, very difficult. And there's some paper that says that, like if you use LLM agents plus um, do parallel search, like for example, you do like 3 queries at a time, you get better results than just a single search. And I mean, this might be a case in point to say that, if I just do beyond what my memory tells me to do, I search more branches, I don't limit myself to memory, maybe I'll do better. I can't remember which paper is this, but there's a paper that does this. So all along, I've been saying that memory is key, right? Like if you look at my past videos, I've been saying, hey, how we learn is through memory. How we learn is the different forms of memory we have. We query them. You can get different like you can get guidance for your action. I think that's only one part of the picture because I've mainly been focusing only on this part of the timeline here. I think what's likely to be game changing is this part here because this part can get you to break free of your memories. Yeah. So this is some new insights I have, just to share.
Sorry, one more quick remark. I don't feel memory is necessarily an obstacle for or always the opposite of exploration. I think if you can make use of memory smartly, it can be good for exploration as well. Because, like, very simple example, we play I don't know, maybe some game, like you explore certain area, but then only because you know you have explored that area and there's nothing good, then you know, okay, I maybe need to explore other area. And another example is for large language model, we all know it memorizes and it remains a mystery, but it's a fact that it memorizes, yet it can still generalize. So all these are like circumstantial evidence that memorization is not always like definitely the enemy of generalization or exploration. Because I think if you are able to do some sophisticated reasoning based off of your memory, it helps generalization and exploration as well.
But you realize for large language models, the reason why generalization might occur in some domains is that you gave it enough diverse training data to begin with. So if you only have one set of training data, like for example, if you just give them an example of using a for loop for programming all the time, you can't expect it to, suddenly do a do while loop. Yeah, because that's out of their kind of.
Oh, it's all a distribution. I agree. So, but my point still stands, right? I'm not saying like you need a smart way of making use of memory, or maybe more diverse memory is needed. I'm not saying that's not important. I'm just saying there's a way to make good use of memory.
Well,
Yeah.
actually, there are a lot of research papers right now that I have on the back burner to dive into. A lot of them, the more recent ones, are trying to experiment with giving like language models and other neural network models self-navigation. Basically, you give the model the reins and you let it navigate its own data set based on what it needs to learn or the goals you set to accomplish.
Sounds like the filter theory that we're having.
Exactly. And it triggered my memory that I'm thinking about. I was like, oh, there's 3 papers I have on that about where you let the model self-navigate the training data set and control its own training process based on a programmed pipeline or like programmed parameters that it follows. And you just let it loose. You let it navigate its own data set instead of like giving it everything, right? You let it train itself on its own data set and navigate the data set by itself in order to accomplish the end goals and the end losses, loss functions. And they get like really good results. I don't have the exact numbers because I don't have the papers in front of me, but they get like really good results. And it's not just being on par with other training paradigms, it's the efficiency. They get insanely vast computation saves. That's much less time steps during the training process to get the same results. So it's much more efficient. You just let the LLM follow the goal and the parameters, and then you let it navigate itself and let it navigate its own data set without control or guidance. Basically, it's the model is guiding itself basically based on how you program it.
Yeah.
I will try to. I'm gonna have to dig them up.
Oh yeah. If you can share the papers, I'll put them in the link as well. So I think what you're describing is something that I strongly believe in. It's called the dynamic intent filtering. So basically, when you gain new experiences, you might want to change your intent to filter out information that is more relevant to the current state. So one case in point is like Google search. So let's say if you have searched for 10 websites, and then you think that, hey, like maybe you search for 10 websites on the topic AI. And then after that, you think that based on what I've seen, I need to search for memory. So then you search again, AI with memory, something like that. And you can refine your search such that you do quite broad and then you go more and more specific to get the data you really need. And in some sense, the universal filter that we have here you can change the filters to suit your goal or your main intent. Your main intent is maybe to find info about memory systems in AI. You can search based on filter based on certain intent. You get the information. You come back, you think about it. Oh, I need more information about this. Then you search again. So in some sense, this is also an AI agentic loop, because you do actions. The action space is to change your filter query. Because by changing your filter query, you get different information back that will feed different parts of the inference loop. Yeah. So I do think that we can do that with all our senses. You can use your sense to focus on different objects. You can get different information. You come back, process again, and then you can filter to some. You can use your senses to query something else. That's for the physical world. In the non-physical world, you can query the database differently to get information. So that is what the whole thing is. So just to, because I think we have about 5 minutes left, let me just talk about how this links to biological memory. So this database thing, the Akashic Records, is not actively available to everyone unless there's a intuition or like you actively query it. And not everyone knows how to query it. Like I myself don't. So if we believe what the psychics are saying, then it is possible to query it. But more conventionally, we have memory systems and the memory systems are used to think. Is it in the brain? I don't know, but it could be in some consciousness realm. So because I've been trying to spend 4 or 5 years trying to find out where the memory is stored, where's our autobiographical memory stored, where's semantic memory, where's procedural memory. I think some forms of memory are in the body, like procedural memory, or like muscle memory could be stored in the body. But I think like stuff like autobiographical memory, it might be in our consciousness, because people who went out of body, they can still remember what experiences they have been, and there's no body involved in it. Yeah, so very controversial here, not accepted in science, but I do think that some form of memory exists outside of the body. Our body, so how I view memory is like this. Our body itself contains memory as well, memory of movement, and like maybe other things, like for example, like intent to movement. So at a lower level, like how to walk, all this have memory in the body. But if we were to accept that there could be something else beyond the body, that we have some form of mind here, and here is where our experiences of our life comes in. And like this is autobiographical memory. Maybe we have like meaning of observations, your reflections, your semantic memory, that might all be here in the mind. So when we talk about like using your past memory to guide your actions, it could be querying two parts. Like you actually don't have to query your body. You can just give your body an intent, like move forward, and then the actions come automatically. Like then you can also query like your mind. You can say, hey, this is school. What memories do I have about the school? And it's a bit hard to disambiguate the two, because we don't feel a difference. We feel that we are the body, but we actually have like some form of processing that happens that is beyond what you can observe in your synapses. This is my belief right now. And this is it is again because our body experiences for clinically dead patients, they can still remember what's going on outside of their body, and there's no activity in the brain at all. So there must be something that is separate from the brain processing. And this is what if we believe in the anecdotal evidence for the near-death experiences. But I do believe there's some form of mind out there that exists beyond the brain, which can store autobiographical memories that, if you believe in reincarnation and so on, um, you might get all this gets stored in some central database, and then like you can access them again the next time you visit that world after you die, that kind of stuff. That is Okay, that we don't have to believe in that, all right? That there's extra stuff, but you can believe that there's two different forms of memory storage, one in the body, one external to it. And similarly, when things happen, there's stimuli in the world, you can actually query this. And this querying might be done automatically. So if it's done automatically, automatic query, which happens sometimes, like you visit a school and then you trigger back memories of your school. This is what Daniel Kahneman terms as system one. If it's a deliberate query, which means that you need to form some form of intentional effort to access those memories, to try to navigate those memories, like, hey, what did I do in my school? What lessons did I take? Who's my teacher? That kind of thing. That is a bit more system two thinking, where you do different steps of inference, different steps of querying, get the data, querying again, get the data. So this deliberate query can also happen with autobiographical memories. All right. In fact, you can also do it for body memories as well. How do I grab the cup? You can query your hand. How do I lift my hands up? Yeah, that is, I think, can happen for both the body and the mind. So this is external to whatever we talk about, the Akashic Records. This one is a database outside of the individual. So this is like a collective database for all individuals that exist. So not everyone can query this, but everyone can query this. Everyone can query this too, because this exists within us. Like, in fact, this also exists within us, but not everyone knows how to do it. So at least for memories and querying, I believe that the way that we query the past experiences could also be done with any like kind of observation we see, any stimuli we see. We can actually query both the body and mind and get information we need to do things. And this can be done automatically, or this can be done deliberately. Okay, yeah, I know I talked quite a lot of like mind-blowing stuff. Let me see the comments. Sorry, you mentioned, to add on to my previous remark, if you believe in evolution, then the inductive biases in genes can be viewed as gained through experience in the grand scheme of things. Yes, definitely. I think the physical world itself learns from experiences and pass on to the next generation in genes. Epigenetics also, you can modify genes expression by basically having certain form of external structures latching on the genes to inhibit the genes expression. That's epigenetics. Yeah, that can also be passed on. All right. Next, Karan says, is that referring to collective consciousness? Okay, so Karan, can I get you to clarify what you mean by this?
Yeah, I'm not really sure. It's like a pseudoscientific term, I believe. It's like something referring to a collective, uh, which is not in the material world, but it's like connecting everybody, and it's somewhere external to us.
Yeah, that is essentially like consciousness. In fact, all consciousness are connected to one another, and that's why you can query stuff like Akashic Records, because this is the database where all the consciousness like can store their information in. Yeah, it's not can, it's like the information is stored there, regardless whether you want it or not. Yeah, so there is collective consciousness. In fact, there have been phenomena where people having the same thoughts can alter random number generators. They can also like affect how computers work. I don't know if you believe in such things, but people have done the power of collective consciousness. There's like global experiments done to see whether like if a collective mind is thinking about thoughts in the same way, like COVID or 9/11 or something like that, it can influence the effects could be observable in the physical world. I have to go and dig up the papers for that, but there are instances where collective consciousness can change reality. Yeah, so I think that answers your question, Karen, or is there something else you want to ask?
Yeah, thank you.
Yeah. So one last slide for today before we end. So we need a kind of time period for reference once we incorporate this time in our information. And basically, by default, you don't have to really query your physical senses for the time. They will just tell you, like they'll process the hearing, and then you'll hear what things are. Because the processing is done independent of your intent. Like unless you say I want to hear my name only, or I want to hear a person's name, then your intent will guide your processing systems to filter differently. All right. So, but the time-wise is always the present, okay? Because our sensory modalities will just give us information. It's like if you're in a game world, the game world will just pump in information to your character every time step. Whether you want it or not, you will get the information, okay, whether you like it or not. So like you cannot say that, hey, I don't want to feel anything in the world for the next 5 hours. Hard to do that unless you do meditation. You try to filter out the senses as much as possible. But otherwise, you will get bombarded with your senses all the time. You don't really stop them. This is something that we are in the game world. We have to receive this information. This is what the game world will tell us, right? And the time wise is normally in the present, and some senses take up to 2 seconds to process. Maybe your vision sense will take a while to see something. So this gets processed the slowest. There's more pathways than the rest, and yeah, this means that whatever you see about the now is actually not the now. It's an inferred awareness of about the now. Like you don't see things real time actually. We see things after it's processed by our brain, which takes a while. Yeah, so what you see is maybe a few, I don't know, milliseconds or nanoseconds, but a few seconds away from the actual real time thing. Yeah, but we don't realize it because to us information flows continuously. Yeah, even if it's a few seconds lag behind reality, it still feels like now. Right. So this querying here for the present is not needed. Like this is automatic. But if you want to query the past, like you want to query your memories, how well you can query your memories depends on how unique this memory is. Because like if you talk about like vector embeddings, maybe if you talk about embedding similarity, if all your memories are in the same place, maybe like if you are at home all the time, like it's hard to say, hey, when's working, when's playing, when's sleeping, like it's all mashed up. Or okay, let's not talk about this. Like what you ate for lunch today, tomorrow, yesterday, today, yesterday, 2 days ago. If you are at the same place all the time, it's very hard to remember what lunch you ate. Okay, but if you are at different places, like day one you go to school, day two you go to workplace, day three you go to the playground, then you might be able to recall better because they're all distinct locations, distinct sensory stimuli. Maybe at one place you realize that, hey, there's a very nice flower scent, and that is so unique you have never not encountered in your entire life. Chances are you remember what lunch you ate that place, okay? Because it's unique. So when you query the memory, what will happen is that you'll get back the memories that are similar, and then it might be all mashed up together. The memories might be like similar memories can be fuzzy. Like it's all mashed up together. And that's also what the psychics report. Also, when they query the Akashic database, if you query too general, what might end up happening is that you get all mashed up into one. Like it's very hard to distinguish what happens in which timeline. Yeah, so I think the memory querying that goes to our memories and to the Akashic records might be the same way of doing it. It's just that one is an individual record, which is our memory, and one is an external record, which is the Akashic database. So yeah, I think querying is important to query very specific and very um, specific memories that can potentially uh maybe it can be unique such that you know that you're querying this memory and not everything else. Like you must disambiguate with the rest. So knowing how unique your memory is important. And for our own biological memories, what attention you give during the remembering is important because your own individual memories, you can only store what you see, or what you process. And not just what you process, what you intentionally want to remember, you can store it. You can intentionally make yourself remember mundane facts by just focusing on those facts. Okay, but if you don't focus on anything, you typically don't remember all these mundane facts. Like like for example, if you are just walking down the street, nothing happens, you potentially won't remember what happened during that walk. Yeah, unless you purposely make yourself remember, hey, how many people pass by you, what color shirts are they wearing, what shoes are they wearing, do they wear specs or not? Yeah, if you focus on all this, you remember those. But if not, you likely won't. So when you want to query the past, if you don't focus on all this, you likely can't remember when you're querying them. Yeah. So this is different for Akashic Records. Okay, let me emphasize this is different because the Akashic Records, whether you whether you have attention during the event, it will be recorded. So you don't have to pay attention to it. The whatever data that is present in the game simulation, you'll be present over there. Yeah. So there's two different kind of memories, and most of the time people would use past memories, which is your own biographical memories. Yeah. So this depends on what you remember in your system. So yeah, and you can use time as a filter to filter those memories. So if you talk about the last minute, then you will access data in the past. And yeah, this time data is a bit different from computer time because in our biological clock, we don't really have very detailed time. Like we only have time that is in our circadian rhythm. Like we don't really remember, hey, this memory stored at 5:23 a.m. unless you look at the clock at that time and that clock appears in your visual memory. Yeah, you don't really have that. Yeah, so I think if we have AI to implement this time filter, it'll be much more superior because you can actually recall your context fully and you can recall with time accuracy in based on the clocks that we store it, like computer time. So it would be better than humans if we implement such AIs with time filters. And just a note before we end today, whatever we talk about, the querying right now so far has been like text. Like I want to query what happened at this place at this time, right? The querying can actually be done with images as well, or like smell, different modality as well. You don't have to use text, or you don't have to use like the verbal thoughts in your brain. You can query it with any sense that you have. Image, smell, taste. So like when you eat certain food, sometimes you automatically remember experiences of you eating similar foods before in the past. Like MasterChef, the judges used to say like, "Oh, this brings me back to Italy," that kind of stuff. This happens with any sense, the querying of memory. Okay, so that's all I want to talk about for today. Yeah, so today we talk about time and how we can use time as a filter. We talk about the global consciousness records called the Akashic Records and how we can query it. And we also talk about our own autobiographical records, like our own biological memory. We can also query it as well. And yeah, a lot of times we don't actively query it. The sense information comes to us directly, but we can actually query it if we want to. And what implications does this all have for AI? How do we learn the filters and so on? I think we'll do that next time. There's still quite a lot of stuff here. So before we end, any last words or thoughts that you have? Okay, if not, thanks so much for coming, and I'll see you again next week. Yeah. Thanks for entertaining all these radical thoughts I have. I still haven't really consolidated them fully, but I do think that I'm on the right track. So if anything else, you read and so on, physical or non-physical, let me know. Maybe you can incorporate into this theory as well. And yeah, see ya.